So, good afternoon, students. Uh, in the last class, we have discussed this non-parametric tests, and in that particularly we have started with the one sample tests, and in one sample test we have discussed three tests. That is Kolmogorov-Smirnov one sample test, KS test. Then we have covered this runs test for randomness, and then we have covered this sign test. Okay, so these three tests we have already discussed, and we have discussed that what non-parametric tests are. Okay, these are distribution free tests and applied when the data on which these tests are conducted does not follow the normal distribution. Okay, so today we will be starting from your chi-square test. So so let us start today's lecture from the chi-square test, and this is one of the very important test, non-parametric test, which is routinely being used. Okay. So let me check whether your chat box is working. Uh, yes, it is working. Okay. So basically, uh, this chi-square test, say for example, in certain market research or field studies, we have responses which can be classified into two mutually exclusive classes, like dislike, or you favor them or you do not favor them, like this. Okay. So the chi-square test of goodness of fit. So this particularly, this test is which is applied on one sample. Okay, this test is also known as chi-square test of goodness of fit. Okay, so Atul, so this goodness of fit is used. Okay, so chi-square test of goodness of fit is used here to test whether a significant difference exists between the observed number of responses and an expected number based on the null hypothesis in each category of class. Okay, so what you will be given with will be observed number of responses, and in one sample test what you have to do is you have to find out the expected number based on the null hypothesis. What is your hypothesis is. Okay, so we will do an example of it, so you will be better in a better position to understand this. Okay, and the so when we will be applying this hypothesis, so the test statistics for chi-square is given by this chi-square is equal to observed frequency minus expected frequency whole square divided by expected frequency. And if you sum them up, if there are k groups are there, okay, so it will give you the chi-square value. Okay, where OI and EI are the observed and expected frequencies in the ith class. Okay, so there brings, and total number of classes are k classes. For a given level of significance alpha, if the calculated value of chi-square is greater than the critical value or the table value, then your null hypothesis is rejected. Okay, so let us do an example of it. Okay, so in example 5, let us consider a textile manufacturer who is interested in studying the customer preference for design before commencing a commercial production. That is, for going for a this commercial production, he first want to test that what is customer preference is there. Okay, so he conducts a survey of 100 customers all over the country and classified their responses in the following way. That is, design 1 was liked by 20 people, design 2 was liked by 30 people, design 3 was liked by 18 people, and design 4 was liked by 32 people. So now here, if a layman is there, then he will think that because design 4 is being liked by 32 people and it is the most preferred design, so I should go with the design 4. But if you have the knowledge of statistics and known parametric test, so you can apply here chi-square test to find out that whether these numbers which you are seeing in front of you, 20, 30, 18 and 32, are merely by chance, or is there a really there is a significant difference in the preference of the customer? Okay, so how to do that? So chi-square test can be used to test the hypothesis that the customer have no preference for any particular design. Okay, so under the null hypothesis of no preference for any design, the expected frequency will be, because here we have to calculate the expected frequency based on our hypothesis, and when our hypothesis is that there is no preference for design. Okay, so it means that all the ratios should come in 1 is to 1 is to 1 is to 1 ratio. That is, the 4 designs should get a ratio of 1 is to 1 is to 1 is to 1. It means if there are 100 customers, so 25 should like design 1, 25 should like design 2, 25 should like design 3, and 25 should like design 4. Okay, so our observed frequencies has been given to you, that is design 1 is liked by 20, design 2 by 30, design 3 by 18, and design 4 by 32. Whereas your expected frequencies are 25, 25, 25, 25, based on our hypothesis that there is no preference among the customers. Now we will find the chi-square test for goodness of fit, that is whether these observed and expected frequencies fit with each other. If they fit, then we will say that there is no difference in these values, and if they do not fit, that is chi-square value calculated comes greater than critical value, then we will say that there is a significant difference among the choice or the preference of the customer. Okay, so how to do that? So what we will be doing, so here what we will be doing, we have to find out the value of O minus E, isn't it? So we have this observed frequencies. What are the observed frequencies we have? We have 20, 30, then 18, and then 32. This is for design 1, design 2, design 3, and design 4. What are the expected frequencies? 25, 25, 25, and 25. So what will be your O minus E? So O minus E will be minus 5. This will be 5. How much will be this? This will be minus 7. And how much will be this? This will be plus 7. So what will be your O minus E whole square? This will be 25. This will be 25. This will be 49. And this will be 49. So now these values, this is what I have done here, that is 20 minus 25 whole square divided by expected frequency. This 30 minus 25 whole square divided by expected frequency. These all values, the chi-square calculated value, it came out to be 5.92. Okay. Now we will see, here we have 4 classes. So the degrees of freedom will be equal to your 4 minus 1, and there are 2, that is observed, and that is, this is how much contingency table? This is 4 by 2. There are 4 columns and 2 rows. So degrees of freedom of this chi-square test can be calculated C minus 1 into R minus 1, which will be equal to 3 into 1. So it will be at 3 degrees of freedom. So what we will be doing, that the critical value for chi-square at 5% level of significance with 3 degrees of freedom is 7.8143473. So for this we have already discussed your chi-square distribution. So there you can find this critical value, and as the calculated value chi-square is less than the critical value, your null hypothesis is rejected. Thus the survey of customer indicates no particular preference for any design. Okay, that is what was our hypothesis. Our hypothesis was that there is no preference of design, right? And your calculated value remains less than your table value, right? So this null hypothesis is accepted actually. Okay. Null hypothesis is accepted. Thus, the survey of customer indicates that there is no preference for any design. That is, all preferences are of equal. Okay. So this is how we do our this chi-square testing. Okay. So this completes our one sample tests. This completes our one sample test. Now we will be starting with the two sample tests. Two sample non-parametric tests. So the two sample tests are used to evaluate the effectiveness or response of two treatments. That is what we are going to do. Whether you will be testing two treatments, or whether you will be testing two methods, or say for example you might be testing teaching or two promotional strategies in marketing. So there will be two groups will be there, which has to be tested with the non-parametric test. Okay. So in each of these cases, the sample which has been administered with the treatment is compared with one which has been administered with another treatment, right? So there will be two treatments will be there, and you will be comparing these two things. The only this thing is there that these groups do not follow the normal distribution. And when they do not follow the normal distribution, these samples from which these from the population from which these samples have been taken, so we will be applying non-parametric test. So earlier we were applying t test, now we will be applying these two sample tests. Okay. So for example, while comparing the two advertising strategies on two group of consumers, one group might react differently compared to the other, not because of the advertisement alone, but also because of the other factors such as their background, social status, etc. So in problem of this type, there can be two independent samples, or the same sample studied again before and after the advertising campaign. Okay. So it can be a before and after case, or it can be two different samples. So they can be compared with each other using these known parametric tests. And what are these known parametric tests? First is sign test. So we have already done with the one sample sign test. Now this test is based on the sign of a pair observation, right? What we will be doing here, we will be giving the sign for a pair observation. So this test particularly used when the measurement of observation are on a qualitative basis. Suppose for example in a market study, the researchers select a panel of 35 people and obtain their attitude towards the company product. He then shows an advertisement and get their responses toward the product. For every person whose rating of the product increased, we have a plus sign. And for those whose rating have declined, we give that a negative sign. So, and for one which remain unchanged, the corresponding sample observation is dropped from the analysis. Okay. So, what is the null hypothesis? Our null hypothesis to be tested in the sign test is that whether your this xa is greater than xb or xa is less than xb. Okay. And when they are equal, it should be half, that is it should not change, right? So when xa is the rating before the advertisement and xb is the rating after the advertisement, right? So in case of small samples, the probability associated with the occurrence of a particular number of plus signs and the minus signs is determined with the help of binomial distribution. That is, if your sample is small, then we apply binomial distribution to calculate the values in this particular sign test, right? And if n is the sample size and x is the number of fewer signs, right? So we will do this, then only you will be in a better position to understand this thing. So let us take an example, and in this example, so to determine the effectiveness of a new traffic control system, the number of accidents that occur at a random sample of 8 dangerous intersections during the 4 week before and 4 week later following the installation of a new system are observed with the following results. Okay. So we had a old traffic control system, and these were the number of accidents at 4 intersections. Then we installed a new system, and these were the number of accidents observed at that intersection. Okay. So because here the in the new system there are less accidents are there. So this minus this, that is new minus old we have to do. So this old minus new. So this will be positive. This will be positive because this is a positive response. That is, earlier there were more accidents and now there are less accidents. But here it will be minus. So it will again be plus, it will again be plus, then it will again be plus, and because there is same number of accidents are there, so there will be nothing will be there, and this will be again plus, right? So say for example, use the sign test at the level of significance alpha is equal to 0.1 to test the null hypothesis that the new traffic control system is an effective as the old system against the alternative hypothesis that the new system is more effective. Okay. So our null hypothesis is that your XA is equal to XB. This is our null hypothesis. And our this alternative hypothesis, this is alternative hypothesis is that XA, this XB is better than this XA, that is the earlier system, right? So there are 6 plus signs. We will count these 1, 2, 3, 4, 5 and 6. And 1 minus sign, and we discard 1 observation. So we have to find the probability of 6 or more successes in 7 trials. That is, we have total how many trials? 7. And out of that we have 6 plus signs. So we have to find the probability of getting 6 or more successes. So with p is equal to 1 by 2, so we have to apply the binomial probability distribution we have already discussed in our earlier chapters. So from there this the probability, this px value can be calculated, and it came out to be 0.063, which is less than the alpha probability value, which is given as 0.10. At 0.10 you have to calculate. So therefore the null hypothesis must be rejected, right? Because it came out to be less. Therefore the new traffic control system is more effective because this null hypothesis is rejected. If this value of p came out to be greater, then this will be accepted, right? So therefore, the new traffic control system is more effective, and note that if our sample size is large, then we may apply the normal approximation of the binomial distribution to carry out as Z test. So this thing I will be showing you in coming example, that how we can use the normal approximation of binomial distribution. Okay. So our second test is chi-square test for 2 by 2 contingency table. That is chi-square test for 2 by 2 contingency table, right? So earlier we have calculated the value for this one sample test. Now there are 2 samples. That is, we have a contingency table of 2 by 2, and earlier we were having only observed frequency. Expected we have some hypothesis, but here there will be no hypothesis on the basis of which we can find the expected frequency. So we have to apply the formula to find out the this chi-square value. So this is done for the chi-square test for 2 by 2 contingency table. And how it is done? So here generally there are 2 groups on the one side of the contingency table, 2 groups on the other side. So these are the frequencies A, B, C and D. So this is the sum of this total A plus C. This is the sum of B plus D, column wise, then row wise A plus B and this C plus D. and if you add all these, so it will be the total number of observation, that is n is equal to a plus b plus c plus d. So this chi-square statistics can be calculated using this formula. And how it is done? That is a into d cross multiplication, a into d minus b into c. So this you can see here, a into d minus b into c. So n into ad minus bc whole square, and multiply all these row and column sums, that is a plus c into b plus d into a plus b into c plus d. So it is in the denominator. So let us do this example, so you will be better understand this thing. So say for example, the mothers of 180 adolescents, some of them were graduates and other non-graduates, were asked whether they agree or disagree on a certain aspect of adolescent behavior. Okay. So we have mothers of 180 adolescents whose children are either graduates or non-graduates, and we ask them some adolescent behavior, and they have to agree whether their child is having that behavior or not having that behavior, right? So is the attitude of their mother related to their educational qualifications? So here this education qualification is of mothers. Okay. So some of the mothers were graduates, some of the mothers were non-graduates, and they have to either agree or disagree on some of the adolescent behavior, right? So what we have to find out is the attitude of their mothers related to their educational qualification, and this data is arranged like this. So we have this A, B, C, D, okay, and then we can find this a plus b, c plus d, then a plus c, then b plus d, and all of them added all together. So we have to apply this chi-square table. So we will apply these values into this, and we get a chi-square value of 19.01. So here degrees of freedom will be row minus 1 into column minus 1. So it will be 2 minus 1 into 2 minus 1. So it will be 1 degree of freedom, right? So on 1 degree of freedom, the critical value of chi-square is 3.84, and this value is greater than this. Okay. And also on 0.01 also, this is 6.63. So this is far greater than this. So the obtained value are much higher than higher. Therefore, chi-square is significant at 0.01 level. So we reject the null hypothesis and conclude that the attitude is related with the education. Okay. What is our null hypothesis? Has to be that the attitudes had nothing to do with the that is on the question asked. Okay, that is attitude versus education qualification. So because here this calculated value is much higher, so our null hypothesis is rejected, and therefore we conclude that the attitude is related with the education. Okay, so this is how we do this chi-square testing. But sometimes what happens that in our data, some of the frequencies are less than 5. Okay, so when chi-square computed from a table in which any experimental frequency is less than 5, then chi-square is not stable. Okay, moreover, in 2 by 2 contingency table, because degrees of freedom are 1, so there are more chances of error. So when any observed frequency is less than 5, in this situation we make a correction for continuity, and it is known as Yates correction. Okay, what it is called as? It is called as Yates correction. So to apply the Yates correction, we subtract 0.05. We subtract 0.05 from the absolute value of the difference between observed and expected frequency. But it can directly be applied into the formula, and your formula, instead of earlier formula, now it becomes n into absolute of AD minus BC minus n by 2 whole square. Okay, so this n by 2 has been introduced, minus n by 2. So let us do an example out of this. So say for example 60 students, 50 from urban and 10 from rural areas were administered attitude scale to measure attitude towards dating. Okay, so some of them expressed positive attitude that dating is good, and some expressed negative attitudes. So we have to find out that whether the attitude of the student will be affected by their belongings, that whether they are from the rural background or urban background. Okay, that is what we have to find out. So here this urban people, out of the 50, 20 says that dating is okay, it is positive. Then 30 says no. And from the rural, 7 says negative remarks while the 3 says positive remarks. So we have to find that this background has anything to do with their attitude towards the dating. Okay. So we will apply here this chi-square testing with Yates correction, because here one of the frequency, this 3, is below 5. So when we will be applying this Yates correction, this is N is 60, then this A into D, 20 into 7 is 140, this 3 into 30 is 90, then 60 by 2 whole square, and these are the values for this 50 and 10. So 50 into 10 into 23 into 37. So this comes out to be 0.056. So entering the table of chi-square, we find that degrees of freedom 1, the value of chi-square at 5% level of significance is 3.841. Therefore, this value is lesser. So the obtained value is less than the table value. Hence, we retain the null hypothesis. That is, our null hypothesis is not rejected, and conclude that the attitude towards dating is not influenced by the person belonging, whether they belongs to a rural people or whether they have a urban background. So this is how we apply the chi-square test in case of two sample tests. Okay, that is, we have rural and urban, and data on their attitude towards the one particular question. Okay, so this is an example that how a chi-square test can be applied to your two sample test. Now our next test is third two sample test is Mann-Whitney U test. Mann-Whitney U test. So this particular test is used to test whether two samples have been drawn from the same population. Okay, what is you have to find out is whether the two samples have been drawn from the same population, and this is a most powerful non-parametric test, as it could be used for both qualitative as well as quantitative data. Okay, that is, whether you have a qualitative data or you have a quantitative data, you can apply Mann-Whitney U test. Okay, so it is very useful alternative to the t-test when you may wish to avoid the assumptions of t-test. You don't have a knowledge about your population, you don't have the assumptions, and you want to bypass them, then you can apply this Mann-Whitney U test, right? So there will be two cases, okay, that when we apply this test. So say for example, we have small samples when neither of the two sample is greater than 8. That is, we have two samples and their number of observations are less than 8, right? So we will be applying this test. So let N1 and N2, where N1 is always less than N2, okay, maybe. So with the number of elements in the two samples, and these samples are pooled together and the elements are arranged in the ascending order of magnitude. The smallest element first and the largest element at the last in the order. So the value of the test statistics U is given as below. Focusing on the sample with lesser in size, that is N1 in number, U is given by the number of times that a score in the group with N2 elements precedes a score in the group with N1 elements. So you will not be able to get this phrase that what I am saying. But when I will be doing the example, you will get an idea that what this phrase is actually telling you, right? So let us do first this example. Then we will be in a position to understand that how this Mann-Whitney U test is applied when we have a small sample size. So let we have two samples, okay, and these are S1 is 11, then 14, 16, 3, and then S2 have 8, 10, 12 and 15. Now we have to test the null hypothesis that the samples are obtained from the same population, right? So the sample size is 3 and 4. So these elements are pooled together and arranged. How they are arranged? That is 8 is obtained from S2. Then greater than that is 10, it is also S2. Okay. Then we have 11, which is from S1. Then we have 12, which is S2. Then we have this 14, which is S1. Then we have S2 15, this is S2, and then we have 16, which is S1, right? Now, to obtain the value of U, we consider the element of the first sample, that is smaller in size. So, in the pooled arrangement, no element of first sample precedes element 8 and 10. So, before this 8 and 10, there are no samples of this S1, isn't it? Right? So, our U value, this U value, these both U2, there is no sample of this your from the sample 1. So, this U will become 0, right? Now, of the second sample, when one element 11 precedes of S1 precedes 12. So then we will go to next S2, and here we have one sample, that is this sample we have. So because preceding this there is one sample, so the value of U will be 1. Now we will come to next S2 class. So next S2 class is here, isn't it? This one, this S2, right? And before this S2 we have two samples, that is one is this S1 and one is this S1, isn't it? So we have at this so one element 11 of S1 precedes 12 of S2, two elements 11 and 14, this means this 11 and this 14, isn't it? These precedes the S1. So here it will be 2, that is this S1 and this S1. So it will be 2. So after that there is no S2, so we will not be calculating. So this U, this will also be 0, because for before this S2 there is no S1, before this S2 there is no S1, before this S2 one S1 is there, before this S2 there are two S1 are there. So 0, 0, 1 and 2. So this U will be equal to 0, 0 plus 0 plus 1 plus 2. So it will be equal to 3. Okay. So this is how this U value is calculated. Okay, so there was a problem in the connection earlier. So now I think it has been resolved, and if it has not been resolved, you can tell me on the WhatsApp. So basically what I was telling uh, is that how to calculate this u. So we have arranged the data, then look for the one which is having less number of observations, so it is s1. So there are nothing before this s2, so it is 0, this s2 0, then this s2 only one s1 is there, and this s2 we have two s1s, so this 2, so 0 plus 0 1 plus 2 is equal to 3. So this is how we find. And then we have this sample size of 3 and 4. Then we look for this table, this one. So if you see that at 3 and 4 we have a value at 5% as 1. Okay, so so basically to reject the null hypothesis at the level of significance alpha, the critical value of u provided in the table must be greater than the compared value of u. Okay, so we have 3, the table value is 1. Okay, so the critical value of the table must be greater, right? So because our table value is lesser than this value, so we will be retaining our null hypothesis. So we can say that these two samples are from the same population, right? So this is how we can apply your this Man's Whitney U test. Okay, now we will be taking up the next case, and then I will be stopping this session, and we will be resuming the next session, and then we will be completing this non-parametric sessions in this non-parametric test in next session. So if say for example your n2 is greater than 9 and 9 to 20, right? So if there are greater than 8, then what we will be doing? So here is an example. Suppose we want to compare here it is a this continuous data, okay, that is quantitative data. So suppose we want to compare the mean lifetime of two kind of 9-volt batteries on the basis of the following lifetimes in hour. Okay, so brand A having this lifetime, and your brand B is having this lifetime, right? So using Mann-Whitney U-test test the hypothesis that there is no difference in the mean lifetime of the two kind of batteries, and you may choose the at 5% level of significance. So how we will be doing? So we have two brands. So I need to that 150. So you will be able to see. No, you will not be able to see. Right. So what we will be doing here. So fine. So what you will be doing, that we will arrange this data in increasing order from the two brands, right? So which is the lowest value? This is 2.4. So we will start from 2.4 and we will go up to the highest value. Say for example, this is 18.2. So how we will do? That is 2.4 is from brand A. Then comes your 6.4, which is also from brand A. Then 6.9, which is from brand A. Then 9 value come, which is from brand B. Then 9.1, 9.3, then 11.1. Like this, we will be arranging these value up to 18.3. Okay. So in total, because there are these 12 in each, so there will be 24 observations, right? So the first value will be given first rank. Because it is from the brand A, so this rank will go into the brand A. Then second rank from the brand A. Then third rank is also from the brand A. Fourth rank is from brand B. Then fifth rank is from brand A. Then sixth rank is also from brand A. Like this, we will be giving all these ranks, right? And then we will sum all these ranks. So for brand A, this rank came out to be 113, the sum of the ranks, and for brand B the sum of the ranks came out to be your 187. So for each value we have to indicate whether it belongs to brand A or brand B. Then rank 1 is given to the lowest value, which is 2.4 in our case. The value 6.4 gets a rank 2 and so on. So you will find that the lifetime of brand A battery occupies these ranks, while those of brand B occupy these. So you may note that there are no ties. So when there will be tie, so we will be doing the mean rank, right? How to do that? That is, you may know that there are no ties here between the values belonging to different sample. However, if there were ties, each of the tied observation would be assigned the mean rank which they jointly occupy. Suppose if the fifth and sixth value are same, so we would assign the rank 5 plus 6 by 2. So both of them will be given 5.5. And if say for example 7, 8th and ninth values were same, so we will give them 7 plus 8 plus 9 divided by 3 equal to 8th rank to all those three items, right? So this is how ranks are given. Now what will be our null hypothesis? That the two samples came from same population, and alternative hypothesis will be that the two samples came from different populations. So we will obtain the value of U1 Benz Whitney U test, that is U1 with the formula N1 N2 into N1 plus 1 divided by 2 minus R1, and this U2 will be given by this formula. So accordingly we find that U1 came out to be 109 and U2 came out to be 35. Now the smaller of the value, that is U1 and U2, which one is smaller? U2 is smaller. So this is our U. So our U will be equal to 39. Say for example, if our this U1 in this example is 109 and U2 is 35. So this makes our U. So our U will be 35, right? So I have a call. हेलो. हाँ डॉक्टर साहब एक क्लास ले रहा हूँ. हाँ हाँ, मैं 5 मिनट में कॉल करता हूँ. So so the smaller of these two will be your value. So for at 5% level, if you see at 12 and 12, the value is 38, okay, which is greater than the calculated value 35. So because table value is greater than 35 calculated value, so therefore your null hypothesis is rejected. Therefore we can say that there is difference in the lifetime of the two kind of brands. Okay, so this is how we can do. Now if you have a sample size larger than 20, that was for 9 to 20. So which is your case 3, then your mean will be equal to n1 n2 by 2, and your standard deviation will be given by this formula, and you have to calculate the z value using this formula. So this has been given here. Say for example, now it has been shown that these are the two populations. Okay, so here again the same type, that is we will arrange these values, okay, and then we will be giving the ranks. And say for example here is the tie at the this 14 and 15 value, so we will be giving this 14.5 to both. And here is a tie at 17 and 18, so we will be giving 17.5 to both. So here this these values will be calculated, and finally this u will be calculated. Once you have u, then you will calculate the mean like this 72, standard deviation like this, and then z can be calculated like this. And at 5% level of significance, you have to apply the z test, and accordingly you can either reject or accept the null hypothesis. So this is the Benz-Whitney U test for two sample tests. Now we will be having a break for around so we will meet at 4:15, okay, for the next session. So this is we have covered only the one test, that is Wilcoxon matched pair signed rank test has been left in the two sample test, and there are two tests in your K sample tests. So we will be completing this in the next session. So as I can see that there are no questions in the chat box. So this is all from my side for this session. So thank you very much for being with me and your patience here.